All right, in this next video, we're gonna jump from side triangle similarity to angle triangle similarity. And before we do that, we're gonna do a quick flashback here to talk about what is the triangle angle sum theorem. What does it say? And remember that says that angles in a triangle or triangle angles add up to be 180 degrees. And so in this case, if we were going to try and find the missing angle measure, we could do that by saying 65 plus 57 is equal to 122, and then we could subtract that from 180, which is the total sum, and we would get our missing angle measure, which is 58 degrees. That's what our missing angle measure would be here. And so when we look at angle triangle similarity, we look at these triangles in this figure. We have triangle KJL and YXZ, and we want to know if these two are similar. And what angle triangle similarity says is that if there are two angles that are the same, then the triangles are similar. And so it's first asked us, do we see any congruent angles? This little tick mark, this one arc and one arc, shows that angle K is congruent to angle Y. Remember that we write congruent with an equal sign and then a little squiggly on top. And then we also show that these two tick marks here show that angle J is congruent to angle X because of the two tick marks here. So how do we know that those two are similar? Because of their tick marks. That's what we call those little arcs. And what can we figure out about the third? Well, we know now that L and Z are also congruent. Angle L is congruent to angle Z. And how do we know this? Well, we know this because of the triangle angle sum theorem. If this one is the same as this one, and this one is the same as this one, and they both have a sum of 180, when we solve for that last angle measure, we're going to find out that they're the same. And so how do we know this? This is because of the triangle angle sum theorem. We know that that last angle has to be whatever's missing from 180. And so write a similarity statement. In this case, triangle KJL is similar to triangle YXZ. And we explain saying that we use the angle similarity statement. Key point, does it matter what order you list the letters? Yes, it most definitely matters. We always have to state the corresponding angles that are equal to one another in the same order. Super duper important that we do that. So now in the practice section, we've got some more problems to try here. It says determine whether triangles are similar. If yes, write a similarity statement and explain our reasoning. So here we have a right angle measure and a right angle measure. It's also telling us that this angle right here is 61, and over here they're telling us that this angle J is 29. That 29 goes with the J. I know it's a little tiny there. But so let's see here. We've got, in this case, this triangle right here. I know that the sum is 180, so I'm going to do 180 minus the 90 degrees from the right angle minus the 61 degrees that I know to try and figure out what my missing angle is. 180 minus 90 minus 61, and I get 29. So I know that my missing angle, angle F, is 29 degrees. Because my missing angle is 29 degrees, and now I have two matching angles, 29 and 90, 29 and 90, I can say that triangle FGH, I'm going to go in order alphabetically here, FGH is similar to triangle. Now this is where I have to make sure that order matters. I did my long side of the right angle and then my short side, and I made my right angle my middle letter. So in this case, J or L is going to be my middle letter. I have to start on the long side, and in this case, that's J to L is my long, and F to G was my long, and then the short side is L to K, LK, and my short side here is G to H. So triangle FGH is similar to triangle JKL. For those of you who are maybe have questions, it is still a true statement to write triangle GHF is similar to triangle LKJ. Again, you can pick what order you want your first triangle to go in, but then your second one has to be in that same order with corresponding angles. So G and L have to correspond just like they do here. G and L are in the middle, G and L are at the beginning. H and K are the same angle. H and K both are 61. And then F and J are both 29. And so we have to list them in a specific order. And our explanation for how we know those two are similar, we say angle, angle, similarity. Now we've got one that's a little bit more tricky. It says, are you given enough information to show that triangle RST is similar to triangle RUV? Explain your reasoning. In this situation, they're telling us that angle S is 48 and angle U is 48. So we see one angle that matches, but we're trying to come up with the second one. Do we have a second one that matches? We know that angle S is congruent to angle U, but do we have a second? Well, they both share R. R is at the top of this triangle. R is also at the top of our bigger triangle here, and it's the same angle for both triangles. So because angle R is congruent to angle R, it's the same as itself, we know that these two triangles are similar. We can say that triangle RST is similar to triangle RUV. Again, notice R and R correspond, S and U correspond, so they're listed second, and then T and V are my last two that don't have an angle marker. And we know this because of angle, angle, similarity. And then the very last one, write a similarity statement for the triangles, then find the value of X, justify your reasoning. We know in this case triangle HJG, I just went from one tick mark, two tick marks, no tick marks, is similar to triangle tick mark KLJ, one tick mark, two tick marks, no tick marks. These two are similar because of they have two matching angles, angle, angle, similarity. And to find the missing value, we know that sides are proportional then, so my long side 9 over my long side X is equal to my short side 6 over my short side 4. I can solve using a proportion and using inverse operations. So 9 times 4 is 36, 6 times X is 6X. Divide both sides by 6, and I get X is equal to 6. That seems like a reasonable answer to say that this is 6. And so here is my answer. The bottom line, if you know two angles in both triangles, you do not need to compare the sides.